Assalamu alaikum students, how are you all? I hope that you all are doing great. Welcome to your channel Math D1D2 Scientific Academy. Today our lecture is related to chapter 9 and your book is D2. The name of the chapter is Geometrical Transformation and I'm going to explain you question number 8 of exercise 9. And students, if you want to get more help regarding your subject, then you can subscribe my channel. Okay, so let's start question 8. Question 8 is, here you can see the question. Question 8 is the point 34 is reflected in the line x is equal to 2 and then reflected in the line y is equal to 1. Find the coordinates of the image of A under these two reflections and state the coordinates of the point which remains invariant under these two reflections. Okay, so first we have to reflect this point in the line x is equal to 2 and then whatever we will get, we have to reflect that point in the line. Okay, so question number 8. Basically, the point A is 3, 4. So to reflect this point, first we have to draw the graph, draw the x-axis and the y-axis. Okay, students, I'm going to take the scale to centimeter 1 unit. Okay, on both axes, on x-axis and y-axis, I'm going to take the scale 2 centimeter 1 unit. Students, remember that if you're having a graph paper of small boxes, then one small box is equal to 1 centimeter. But if we talk about these big boxes graph, so a half box is equal to 1 centimeter and a complete box is equal to 2 centimeters. So I will leave a complete box and 2 centimeter and 1 unit mean that I will give the gap of one number. So 0, 1, 2, 3, 4 and here this is -1, -2, -3 and -4. Here positive 1, 2, 3, 4 and -1, -2, -3 and -4. Okay, first I will plot this point which is 3, 4. Okay, 3, 4, 3x, 3 is here and 4 will come here and this is y4. So it means that this is your point which is A point and that is 3, 4. Now we have to reflect this point first in the line x is equal to 2 and then in the line y is equal to 1. So first you have to draw these two lines. Students, remember that whenever you're having any constant, x is equal to any constant, it means that you have to draw a vertical line. X, whenever it's the line of x, so you have to draw a vertical line that will pass through this constant. So x is equal to 2 means that it will be a vertical line which will pass through 2. So you have to draw a vertical line. So this is our line x is equal to 2. So this is our line x is equal to 2. Okay, so remember that whenever you're having y is equal to constant, it means that it is a horizontal line which will pass through constant. Whenever it comes y, you have to draw a horizontal line. So y is equal to 1 mean that horizontal line which will pass through 1. So draw the line y is equal to 1. So this is the line y is equal to 1. Okay, now first you have to reflect this point in the line x is equal to 2. So this is the line x is equal to 2. So first reflect this point on this line. Students, remember that whenever you reflect the point, so keep in mind that first you have to see the distance. As you can see that the distance of this original point from this line of reflection is 1 box, or you can count the units. Here you can see that this is 1 unit from 2 to 3. From here to here, there is a gap of 1 unit. Okay, 1 box. So when you will reflect this point, you will go on the other side of the line with the same distance. The distance from here till this line is 1 box. Go to the other side with 1 box as well. From here till here, it's 1 box. Okay, so the distance of this original point from this line and the distance of this reflected point from this line is equal. As you can see that these 2 points are equidistant from this line. the original point and the reflected point. So you have to go with the same distance on the other side of the line. Okay, so what are the coordinates of this point? Okay, here x is 1 and y is 4. So these are the coordinates of reflected point, 1, 4. Okay, students, now you have to reflect this point, because in the question they have asked you first reflect the point in the line x is equal to 2 and then y is equal to 1. Now we have to reflect this point in this line, which is y is equal to 1. Again, you will do the same method. You will count the distance from this line. Okay, you have to count the distance of this point from this line, and then you have to go with the same distance on the other side of the line. So we are considering this line, which is y is equal to 1. So count the distance from this point to this line. You can count the units, 1, 2, 3. So there is a distance of 3 boxes, or in other words, there is a distance of 3 units. Now go on the other side of the line with 3 units, 1, 2, 3. So here it comes 3 units. Length would be remain same here. 3 units here. Go to the other side of the line with the same distance, 1, 2, 3. So this is the point. And here x is 1 and y is minus 2. So when you reflect the point in the line x is equal to 2, you will get the coordinates 1, 4. And when you reflect the line, reflect this point in the line y is equal to 1, so you will get the coordinates 1, minus 2. Okay, G. So this is how you have to reflect the points. Okay, students, now the next question, okay, the next part of this question is state the coordinates of the point which remains invariant under these two reflections. So first here, let me tell you that what are the points which are invariant. So invariant are the points which are on the mirror line, okay, which you cannot reflect those points. Okay, so here in this case you have to find out that point that will not be reflected. Okay, because so it means that is the point where both lines are intersecting, because that point could be the only point which is invariant and which cannot be reflected. Okay, so that point will be the point where two coordinates will intersect where two lines intersect each other. So here you can see that this is the point. This is the line x is equal to 2 and this is the line y is equal to 1. So this is the point where two lines are intersecting and where the point is invariant, which cannot be reflected. So we will say that here the coordinates are, the x is 2 and here you can see the y, here the y is 1. So you will say that, okay, part 2, you will say that in part 2, the point which is invariant is two, 1. Okay, students, so let's have a okay, let's revise that what we have done in this question. In the question it was asked that the point is given to you. First you have to reflect this point in the line x is equal to 2, and then whatever you will get, you have to reflect that point in the line y is equal to 1. So first you plotted the original point, which is 3, 4, and then you have drawn two lines that y is equal to 1 and x is equal to 2. So first you have to reflect the point in the line x is equal to 2. So you have to count the distance of the point from the line and you have to go with the same distance on the other side of the line. So you will get 1, 4. In the same way, yeah, and you have to reflect this point to this line, because it is written that after this you have to reflect this point in the line y is equal to 1. So this is the line y is equal to 1. So you have to reflect the point from this line. So you have to count the distance from this line. So you can see that the distance is 1, 2, 3. There are 3 boxes. So you have to go with the same distance to the other side of the line. So 1, 2, 3. So this will be your reflected point, and the coordinates of that point is 1, minus 2. Okay. So this is all about part 1. So now when you will talk, you will go for part 2. In the part 2 they ask you to find out the coordinates of the point which remains invariant, okay, under these two reflections. It means that that is the point which cannot be reflected, okay, that is the point on the mirror line which cannot be reflected. So for that you have to see that where two mirror lines are intersecting each other. So this is the first mirror line, this is the second. So both mirror lines are intersecting at this point, which is 2 and 1. So this is the point, or these are the coordinates, this is the point, and these are the coordinates of the point, which is we can say that the coordinates which remains invariant under these two reflections. Okay students, I hope that today's concept is clear to you, the practice of this sum, because when you redo the practice then this concept will be more clear to you. Take a very good care of yourself. Thank you very much, and Allah Hafiz.